Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 to night flight with Remy over flying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit instruments, the displays, and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator, the airspeed selected from the pilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb of the aircraft in 10,000 feet per minute, or the steepness of the trigonometric countings degrees can climb descent. We have also the altitude indicator with the artificial horizon, the pitch ladder in degrees, and the bank angle in degrees. We have also the ILS localizer, the instrument landing system of the threshold runways antennas of the runways we use for takeoff and for landing. So the threshold antennas transmit the radio frequency we receive from the onboard antennas of the aircraft. The ILS localizer, and we can align with the horizontal localizer or the vertical glide slope, the angle of approach. So we have the ILS localizer crossbars also displayed in the primary flight display. We have to tune a unique radio frequency each time we use a separate runway and airport and runway magnetic north pole heading we have to set from the autopilot panel for alignment. So you're gonna see how we're gonna do that. So we have the ILS localizer crossbars, we have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and on zero with the autopilot and the autothrottle. Later on vertical navigation modes, we have also the edge side, the horizontal situation indicator with a magnetic heading and track. We have the integrated display of the flight plan. So we're gonna create a flight plan or a flight path or a route using the flight management computer. You're gonna see it later. It's gonna display both in the HSI here and the horizontal and vertical profile of the navigation display. You will see the flight plan we're gonna create, and it's gonna be followed by the autopilot flight director system panel. In flight, when we connect the autopilot flight director system panel, it's gonna follow the flight plan we created one waypoint by another. So we have also the navigation display that displays the GPS position of the aircraft, the magnetic north pole and the geographic north pole and magnetic variation depending where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the terrain elevation displayed with a red, green, yellow and amber color indication depending of the distance of the terrain away from the aircraft or below. Also in an inclination with the aircraft when we climb the descent. We can see the altitude from the antenna radio receiver above the ground level when the aircraft is flying up to 2,500 feet in the primary flight display, as you can see here, and also in the navigation display you see later up to 5,000-6,000 feet, maybe higher. So we have also the lakes, the rivers, and the sea displayed with a blue. We have also the terrain map displays the airports where they are located. Our own airport, the Lszh, the Zurich International Airport in Switzerland. We have the runways we're gonna use for takeoff and for landing are displayed, the runway length and heading. Also the taxiways, we can taxi the aircraft into the runways using the GPS display. So we have also the navigation aids, the nav aids, which are the work stations, ADFs and NDBs, and the waypoints. The waypoints, which are horizontal and vertical navigation fixes and altitude and airspeed constraints. You're gonna see later through the flight management computer here. I will input all the data of this aircraft for this flight. So it's gonna follow one waypoint by another. The route we're gonna create for flying the aircraft, the Boeing 787-900. So we're gonna have also the navigation display. We have also the horizontal, the vertical. We have other aircraft that fly around our own aircraft. Are displayed from the transporter. The display ADC transmitter receiver that transmits a radio frequency to other aircraft, and the air traffic control receives from other aircraft. You can calculate with its computer the other aircraft distance from our aircraft up to 40 nautical miles or 72 kilometers away in a 360 degrees radial around the aircraft. You can calculate the altitude difference between our aircraft and the other aircraft in hundreds and thousands of feet above or below, and also whether the other aircraft climb or descend with respect to our aircraft. You can also display the other aircraft with the diamond shape on the navigation display with the altitude difference next to it with a plus and minus sign, and also narrow up and narrow down, indicating whether the other aircraft is climbing or descending with respect to our aircraft. You can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision advisory system. If we have an incoming collision with another aircraft in the air, we'll make an avoidance maneuver. So we have also the terrain, we have also the TCAS, the transporter can see other aircraft in the ground, in the taxiways and the runways in the airport we use. So I will display them in the navigation display. So we have also other systems you're gonna see, the autopilot flight director system panel, flight management computer, the engines indications, the ACAS, and other system indications in the multifunction display, the thrust levers. Over here the flight controls. I will show you the flight controls of the Boeing 787. So I have the full setup for flying this aircraft. This time I have again the mouse pad here to control the autopilot, and the flight management computer, the keyboards I need for the autopilot, and also the mouse pad for clicking all the buttons. Over here also in the controls the thrust levers. So we have the side stick here, the Lszh Extreme 3D is identical to the Airbus aircraft. So you can see we can climb, we can descend, we can make turns to the right and to the left. So you will see the elevator climb, descend, and also make turns right and left. We have the control wheel for left and right turns in the Boeing aircraft. We have the side stick in the Airbus. So there is no difference in the flight control system. Also you can see we have the rudder pedals. Over here we can make left and right turns using the rudder pedals input. So you can see a left or a right turn like this. In the air we can use the rudder, the vertical rudder, left and right input when we fly to make the aircraft left and right turns like this, as you can see, using the rudder pedal. So you can see the rudder moving. And also when we are in the ground and we move the rudder pedals like this, we have also the nose wheel steering through the tiller interconnected in both rudder pedals. So we can use the nose wheel steering also. Over here you can see the forward nose wheel. So we can control left and right turns. I will talk to you about now in a couple of minutes. So we have the elevator, climb and descend like this. As you can see, ailerons and spoilers. So we have advanced. Oh, we had some mistakes here. I had no flaps for a while, so I got them now. Because I forgot the advanced animations. So we have all the systems we need for this flight in the Boeing 787 900 aircraft. I will show you the flight controls. So we climb, we descend, you see the elevator moving for climb and descend like this. Side stick, pull up the elevator, pull down the elevator, also make left and right turns, the ailerons and the spoilers like this, as you can see. So I will show you how to control all the flight controls of the aircraft of the Boeing 787. Also the inside view. So I will talk to you now about the Newton's physics, about the aeronautical and aerospace engineering, and I derived some principles we need to know for the air transport pilot license and the commercial pilot license, the ATPL theory and the CPL theory. We need to know flight dynamics and aerodynamics, and also aerospace engineering. So also the outside view, and also the flight controls, how they function. So you can see the cockpit again one more time. I'll show you later the displays, also how to use the flight controls inside. So you can see here we have the outside view of the aircraft. You can see the surface area of the wings hold the weight of the aircraft when we fly. The weight is divided over the surface area of the wings. Also we have the lift acts over the weight over here. Where is the center of pressure of the lift over here? Where is the engines? It's falling on the left and the right wing. So the lift overcomes the weight and the thrust from the engines, from the jet engines, because we have a jet airplane, very beautiful jet aircraft, the most advanced in the world. So we overcome the thrust, overcomes the drag of the skin friction and of the wings mainly. So we have over here, you can see the engines. You can see we have lower below the wings. We have higher pressure when the aircraft is flying like 300 kilometers an hour. So the air is pressurizing the weight in the wings of the aircraft up into the air. Also, as we increase airspeed like Mach 0.9, like 900 kilometers an hour, we're going to be having higher air pressure. Also, the top surface, we have lower pressure because the airspeed is moving faster above the wings using the Bernoulli theory of fluids. Also, you can see over here we have the engines installed. You can see the high pressure compressor and turbine in the back section, and the high speed starter and shaft. Also the low pressure compressor and turbine below, and the front fan. And we have the combustion chamber over here for the engines. You can see the turbofan. We have the bypasser from the turbofans that push the aircraft forward like this. So we have also the thrust reversers. Over here we have the fuel lines. The fuel of the aircraft is coming down through the suspensions of the jet engines, because we have the left wing tank and the right wing tank, the fuel booster pumps over here, and the low and high pressure fuel valves. We have the center tank over here, the mineral dynamic cord, about 33% of the Mach, where the maximum aerodynamic lift occurs. The center of pressure is moving back and forth. And we have also the stall will occur over here, the mineral dynamic cord at 23% of the Mach, the stall, the airflow becomes detached when we fly. So you will notice here when we fly, the stall is gonna be displayed in the primary flight display over here in the display. You can see the primary flight display, we have the airspeed indicated, and the stall speed is gonna be displayed with yellow and red indications as below the airspeed as we fly. Also, you need to pay attention to the angle of stall. So if you stall the aircraft, you apply the side stick down in the Airbus, or the yoke down to decrease the angle of attack, and then you advance the thrust levers forward to increase the airspeed. Also in the Airbus you may have the alpha protection system, which is gonna lock the takeoff ground automatically. So we have over here, you can see the aerodynamic cord. Here's the center of gravity for the aircraft, is the yawing axis through which we yaw the aircraft wings, the rudder, left and right turns like this. So this is the yawing axis of the aircraft. Very important to know. So we make left and right turns over here. Press the rudder pedals left and right in the air. You will use directional control. Both rudder pedals in the Boeing, the Airbus, the Embraer aircraft, and the CRJ are interconnected when we fly. Also, we'll show you the rest of the controls. So we have also the nose wheel is deflected when we are in the ground together with the rudder. So the nose wheel is deflected left and right turns, 76 degrees left and right for nose wheel steering in the ground or in takeoff and in landing. 76 degrees from 0 up to 45 knots nautical miles per hour, 45 nautical miles per hour, or 72 kilometers an hour. Then the rudder becomes more aerodynamically effective, as you can see. So the computer will limit automatically, you don't need to do nothing, the deflection of the rudder pedals of the nose wheel steering from 76 down to 7.6 degrees. You may deflect the rudder pedals all the way down, but The nose will deflect only 7.6. The rudder is gonna be more aerodynamically effective. Then as you increase your airspeed above 80 knots or 144 kilometers an hour in takeoff, the nose will be locked to zero deflection from the computer automatically, or a small deflection like half or 1 degree. So above 250 kilometers an hour in takeoff or in landing, you have only the rudder for control, like 140 nautical miles per hour, 140, 150 knots, or 250 kilometers an hour. So you have the rudder pedals over here to control this, the rudder or the nose wheel together with the rudder in the ground. Also, when you land the aircraft, you have first the rudder, like 250 kilometers airspeed. Then as you slowing down the aircraft, as you touch all the wheels down and you slow down below your airspeed, the nose wheel is becoming activated from the computer again. You don't need to do nothing for that. The computer of the aircraft, of course. So this is the rudder pedals. So we have also one more axis here from wingtip to wingtip. It's the pitch axis, as you can see. So we can use the elevator. So the side stick climb and descent in the Airbus is the Boeing yoke back and forth. So we take the weight up, we climb, we take the weight down. We descend using the tail of the aircraft. We can also trim the tail. We have a trim switch, both switches, trim down and trim up. For the horizontal elevator or the stabilizer, horizontal stabilizer. So we have one left and one right horizontal stabilizer. So you climb the side stick back and forth in the Airbus. In the Boeing you have the yoke, very easy to remember. Same thing, the same deflection, difference between the Airbus and the Boeing aircraft, as you can see. So you climb with the Airbus, you pull the side stick up, you pull the weight up, and the Boeing also you pull the weight up with the yoke. This control column of the yoke of the Boeing 787, as you can see. So we have all flight controls, all like this, very easy. Also the other side is interconnected together, so they move together and fly. So we climb with descent, we use the elevator. Also we have one more axis here, is the from nose to tail is the roll axis in the Airbus aircraft, using the side stick to make left and right turns, using the ailerons and the spoilers. So use the ailerons here and the spoilers. You can see in the left and right wing. So you make left turn or you make right turn by using differential lift air pressure between the left and the right wing. We make the aircraft roll in the flight. You can apply also the elevator to climb you or descend you, keep you level and the rudder. So you roll left, right side stick in the Airbus, ailerons and spoilers. Left side stick, you can see ailerons here and spoilers over here. Also spoilers extended, and also in the Boeing we have the flap run. Down here we have the flaps fully extended, like this. So it's easy to remember. We have a few more things to see over here. So this is the flight controls, control wheel, left and right turns, like in the Airbus side stick, right and left. Ailerons, spoilers and flap runs in the Boeing, ailerons, spoilers in the Airbus. No difference of the flight control, same feeling in the air. Since we have also flight control computers, I will explain it now. It's a fly-by-wire aircraft. It has its primary flight control computers over here. So in the auto position we have the normal, the alternate and the direct mode of the flight control computers. So we have the normal, the alternate and the direct mode of the flight control computers when flying the Boeing aircraft. Also mechanical backup like in the Airbus aircraft. We have the normal, the alternate and the direct mode of the flight control computers, the control of the flight controls in flight. In normal mode, when we move the side stick, I will explain it now. So we just spoiled an aircraft for landing over here. You can see a Boeing 737-800. Here it comes. we just spotted 737-800. This yellow and white. Just start now. So we have over here the horizontal trim stabilizer, and also the alternate, the normal and the alternate, which is manual stabilizer control. When flying manually, you use the elevator for climb and descent in the Boeing aircraft. Like this, pitch the nose, the nose up when flying, or trim the elevator up and pitch the nose down, or trim the elevator down like this. So you can see elevator trim. Elevator trim, left click down, right click up. So this way you trim the elevator up, this way you trim the elevator down. So you pitch the nose up, you have this aerodynamic effect, pitch the nose up and pitch the nose down as you fly. Also use the control wheels over here, the control wheel of the aircraft, the Boeing 787, the control column. So we trim the elevator up like this, and we trim the elevator down like this. We have the autopilot disconnect switch and the head up declutter switch, the flaps limits over here. So we use the horizontal trim stabilizer. This is a fly-by-wire aircraft. As I told you, it has also its flight control computers to trim the aircraft automatically when we fly without doing any input in this switch for the horizontal stabilizer or the alternate, or the trim wheel. Some aircraft like the Boeing 737, it has the trim wheel. Also all the Airbus aircraft have trim wheels. The newer Boeing aircraft that have only trim tabs or trim switches, like the Boeing 787 or the Boeing 777 or 767, 757, 747. So the trim switches are used for the horizontal stabilizer over here to trim the elevator, as you can see. So we trim like this, pitch up and pitch down. It balances the aircraft in flight very easy. So we have also the auto trim, as I telling you. So the auto trim function, if you have a failure of the flight control computers, because you have a failure of some aircraft systems like the hydraulics, because of an engine failure, it will degrade the flight control computers from normal to alternate to direct mode or mechanical backup. So you're gonna lose the auto trim function. You have to disconnect here this switch. I will show you. Also, you will this is for the Boeing aircraft, the Boeing 787, Boeing 777, and other aircraft Boeing manufacturers. So you have the hydraulics. Here you can see left and right engine driving electric C1 and C2, the pumps. We have also the flight control computers. If you have failure of the hydraulics, here will affect the flight control computers. You're gonna lose the autopilot probably, because you're gonna have no auto trim function. So you'll see also the autopilot in a couple of minutes. All systems here, how to use it before flight. So you come down here, you see we have the alternate also. Stabilizer nose up and nose down. You can see alternate pitch trim. So this way you trim the elevator up, you pitch the nose up, and this way you trim the elevator down, you pitch the nose down. As you fly, you have this aerodynamic effect. Also you have the parking brake. We have the stabilizer cutoff switch over here for this system, for the stabilizer trim, for the auto trim function that I tell you. We have failure of the flight control of the systems that will affect the horizontal, the left or the right stabilizer. As you can see, you need to come down, open this from normal to cut off, either the left or the right, or together, both of them. You have both of them fail. So this is you have failure of the hydraulic system. Here will degrade the flight control computers. The auto trim function from the autopilot and the auto flight director and other functions will be compromised. So this is for Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, and Boeing 787. You open this red guarded switch over here from normal to cut off. As you can see, stabilizer cut off switch. So you use only the manual switch for trimming the elevator, no problem to that. You flying also manually like this, trim the elevator up and down. You can see also the sweep-over was 30. So I would say, you know, the stabilizer trim. So the stabilizer trim, you can use the pitch trim down or the pitch for the stabilizer trim over here. Also the rudder trim. Also the flaps position when you fly. Also the landing gear extend and retract. The alternate gear over here. You use the lock override also. So you pull up or pull down the landing gear. And also you can use the auto brakes, rejected takeoff, maximum, disarm, 1, 2, 3 over here. So the stabilizer trimming will be displayed here. You can see also the cabin pressurization over here, the cabin altitude, outflow valves, forward and aft position, open and climb and descent. Also the rate of climb and descent, differential pressure, landing altitude. So you see the elevator function, also the stabilizer trim. So we have the normal control suites over here for flying the aircraft manually. Also the flight controls, all flight controls together, interconnected flight controls, both left and right. So we have the side stick priority button for the Airbus aircraft. We can take side stick priority, the left and right side, the push to talk, and the autopilot disengage button for the Airbus aircraft. Also you can see we have also, as I told you, this is a fly-by-wire aircraft, both Boeing 787, Boeing 777, 300ER, for instance, the Worldliner aircraft and the Dreamliner aircraft. So the Airbus 330, 340, 320 have flight control computers. When we fly, they limit the aircraft flight control deflections for optimum performance in terms of G acceleration, where G is the Earth gravity, 1G. So when we fly level 1 G acceleration will be optimized by the flight control computers of the Airbus aircraft, leaving the side stick neutral. Also when we make turns, left and right turns with the Airbus aircraft, left turn is going to be 2.8 G or 67 degrees maximum deflection, or right turn 2.8 G. Also climb 30 degrees or 1.5 G, and descend minus 15 degrees or minus half G. So you can see here we can climb 30 degrees with the Airbus aircraft, or 1.5 G. We can descend minus half degrees or minus half G. We can also make turns 67 degrees left and right with the Airbus aircraft, or 2.8 G acceleration at maximum side stick deflection. This is for Airbus 330, 340 and Airbus 320 aircraft. Also when we release the side stick at maximum deflection from 67 degrees, the computer will return the aircraft to 33 degrees bank angle, either left and right. Also we need to input more side stick to leveling off and hold 1G in flight. So this is some of the flight control computers which controls the Airbus aircraft, Airbus A320, A330, A340. Also the Boeing 777 and Boeing 787 aircraft have similar flight control computers inputs. Also the auto trim function. Also we have a trim wheel over here for the Airbus aircraft and the Boeing 737. This has only trim switches, as you can see, like the Airbus aircraft have trim switches over here. All the CRJ aircraft have trim switches over here, and here in the control wheel. Also we have the alpha protection system when we fly the aircraft with an angle of attack and airspeed that is gonna stall the Airbus aircraft in the air. the flight control computers are gonna limit the angle of attack of the aircraft at minus 2 degrees usually, and lock the takeoff ground thrust, maximum takeoff thrust lock. So this is some of the features: alpha protection, minimum speed, also overspeed, maximum Mach operating speed, other spot protections like flap speeds. So we have similar things for the Boeing. You will see now the other systems, also the flight controls. So before we go for the rest of the systems, I'll show you one more view of the flight controls of the Boeing 787. I hope you like also the screen view of the Boeing 787 aircraft over here. So you can see. So we can see, we can climb, we can descend, we can make turns to the right, turns to the left. So turns to the right in the Airbus, you remember, is limited. Some degrees deflection, or G's, 67 degrees. So you see the Boeing is similar in controls, left and right turns. The deflection of the control wheel over here is identical to the Airbus aircraft. Also the climb and descent, the control wheel input of the Boeing, or the side stick back and forth of the Airbus, like this. Also you can see in the Airbus and the Boeing we have the thrust control over here, using this slider, so we can actuate the thrust control. You can see what percentage of engine thrust is produced over here when flying. So climb, descend, make turns to the right, make turns to the left. You can see the screens. Both controls are interconnected in the Boeing. The captain and the first officer, you need to apply some override force when flying to control either side. So in the Airbus you just have the side stick priority or dual input. So we have the outside view. You can see we can climb and we can descend. Rudder pedals again, ailerons and spoilers, like this, very easy. So ailerons and spoilers, left and right turns, climb, descent, elevator control, rate of climb, descent, also rudder over here, dynamic of the aircraft that we need for the air transport pilot license and the commercial pilot license, how to know how the aircraft is operated, all the systems one by one. So this is most for the flight controls tonight. I hope you like. Also the side stick that I have here, which is for the Airbus, as you can see. So climb, descend, make turns, all flight controls together, interconnected in the air. And the thrust levers and the stabilizer trim. So we have here, you can see the rest of the systems. Now I will make the flight management computer inputs what we need to create a flight plan for this flight, and then I will show you the rest of the systems before we go into flight. So I need to lose no time right now. I will show you again the controls, the setup that I have, the computer over here to control the aircraft, also the inputs for the displays here, the flight management computer. So we have the mouse pad here to input the data. We need touch screen over here. You can use the CDU control display unit over here, and the keyboard functions CDU. We have one more aircraft coming down for touchdown, Boeing 737. So we input all the data, you can see through the mouse pad of the Boeing 787. So we have the screen, identity, position, performance, takeoff, approach. We can also modify that when we fly the data. So we have the control quadrant here, input all the data that we need, also the control the autopilot. So we have identity over here, Boeing 787-900 GNX engines, the air cycle, position, Lszh, in Switzerland, Zurich International Airport. So we can align also the GPS and the inertial reference system of the aircraft with the longitude and latitude, magnetic and geographic north pole, zero fuel weight, fuel on board, gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel, freezing temperature in flight, cruising center of gravity. So we use the route first. We have the Lszh. We tried at the ranked input for the fuel, so we have to clear that. Lszh, back to Lszh, departures and arrivals over here. So we copy paste here. We need to be a little bit more brief. Runway 14 over here, select runway 14, departures. So we select departures over here. So we have the reserve fuel 5%. So the route Lszh departures over here. I messed up something, I believe, with the request fuel. So we have to select runway 10, 1416 2832, either runway. So we select runway 14, Trans Zui. We select the Cs, these are the instrument departure waypoints and fixes. That include horizontal and vertical navigation fixes and altitude and airspeed constraints. So we use the arrival here. Let's see its arrival. You can select ILS runway 16 to 834 ILS 14 ILS 16 ILS 34 ILS 28 ILS 34. So we select ILS 14 Trans Samiki and Trans Negria over here. So we have the legs over here, departure and arrival, the route. So we use the first waypoint after departure over here, intercept, and also we have to climb through the Zui, which is this distance. The autopilot, we're gonna use that. So we need to activate reserve fuel, cruising altitude 35,300 feet over here. And the cost index 100%. It will activate now the legs like this. The route is activated. So we have activated the route like this. So we input everything that we need, the departure, arrival, trans the waypoints over here. So we have the legs ready. We set the flaps for takeoff 15 degrees, center of gravity 23%, 4.35 Decrease in the takeoff speeds, V1 we rotate V2, gross weight for takeoff, runway position. So go back in the cockpit. And we have back the axis indicator, thankfully. So we have the route first waypoint after takeoff. It's going to be followed by the autopilot Zui, 6 nautical miles, climb to the Nigria, make a right turn over here, 300 knots by level to the 2200, then descend approach 0701 and landing. So this is the full flight plan. We have also a departure arrival, alternate VNAV, progress, FMC communications, hold over a waypoint, fix, set a fix radio, Q9 Lszh localizer for ADF. So we have going back to the cockpit over here, as you can see. So we can go around like this outside. So we're going back in the virtual cockpit like this, and we have a few more minutes to go. So I will show you the rest of the systems now. Set up the overhead panel. I will show you also the flight plan and the primary flight display and the navigation display, the airspeed indicated. So I will show you also the overhead panel. Set up the APU, the accelerated power unit, to start the engines. So we have the airspeed indicated here. The airspeed selected from the autopilot flight director system panel, the flight director, the pitch added 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 30 degrees for pitch up and pitch down, the bank roll like 10, 20, 30, 45, 60 degrees. Also the altitude, barometric altitude 1430 feet, barometric pressure 39.92 inches of mercury, or 1013 hectopascals. We set the barometric altitude same like the altitude of the airport that we are located right now. We can set here inches of mercury, hectopascals, 1013 hectopascals. Radio baro increase and decrease. It will increase or decrease the barometric altitude displayed here. It should be same like the airport we use for flying the aircraft. So we have also weather radar, traffic, accept, cancel, reject some warning systems over here. The autopilot flight director system panel, also the engines indications, left and right engine, the cabin pressurization. I saw you before. So we have the display here also. You can see the aircraft displayed, the flight plan, and the runway we're gonna use for takeoff and for landing over here. We're flying the aircraft. So you can see center on. You can see here we have now the runways we're gonna use for takeoff and for landing. The taxiway in front of us, the terrain elevation. Also, when we fly the aircraft, you're gonna see the terrain in front of you. We have the airspeed, altitude, pitch, altitude, vertical rate of climb, descent. So you can see here we have the taxiway in front of us, the other runway over here. So we have also here, you can see the outside view. So we have the virtual cockpit. We need to start now the engines, as you can see. So we move over here. We need to set up the APU, start the engines like this. So we set the APU to the start position like this. Also we have the IDZ left and right engine driving, 100 to 200 volts, 400 Hz frequency. The batteries over here, as you can see, the controllers, the hydraulics. We can turn the hydraulics on and off. So you can see also from the outside view, you have the view over here. So when you look in the virtual cockpit like this, we have to set the aircraft systems back to the display over here. You can see the terrain, also the ground. So we have here the IDZ left and right engine driving, electric C1 and C2, the battery, electric in the auto position, air data computer, primary flight control computer, the batteries over here, FD door, passenger oxygen, window heat, electronic engine control for the engines, the hydraulics. We will turn off what will display a fault like this. The wing and engine RDIs over here, position. Cabin pressurization, manual, use the outflow valves, climb, descend, depressurize the aircraft. Air conditioning, we have pressurized air from the engines for oxygen, for cabin pressurization, hydraulic fluid tanks pressurization, also wing and engine RDIs. We have the APU fire over here, cargo fire, the engine, electronic engine control for the engines in the start position. Also electronic engine control modes for the FAREX, fuel jettison. We can dump some fuel in flight to make an emergency landing and select the nozzle how much to remain. Fuel booster pumps, left and right engine driving, center pumps, the crossfeed valve, we turn it on. You can feed either engine with either pump or either tank and balance the fuel between the left and right wing. So we can see also the systems we have here for flying the aircraft, a few more systems, also the lights we need to turn on like this. So we go for the engine start demonstration very quickly. You can see here we have the hydraulics, pressure, APU is running, oxygen and liquid cooling over here, oxygen quality, the electric left and right IDZ, the gray drive generator, 100 to 200 volts, 400 Hz frequency, the main battery over here, an APU battery, the voltage also, the hydraulics, where the hydraulic fluid goes, which systems use hydraulic fluid over here, left and right engine driving, primary electric C1 and C2, the pressure 5000 psi also, the fuel, left and right wing fuel tank, center tank, low and high pressure fuel valves, left and right engine driving. The APU is fed from the left wing using the DC motor. Total fuel on board the aircraft 33,000 pounds. The total. The minimum fuel temperature minus 33 degrees right now over here. So the aircraft FADEX, the full authority electronic control computers, will transfer fuel automatically from the left and the right wing into the engines component to heat up the fuel in flight to avoid the fuel freezing. We have the fuel transfer and then return to the tanks. Also the lubricant and the oil. You can see minimum fuel temperature. The crossfeed valve, we turn it on. You can feed either engine without the pump or the tank. The pressurizer, cabin pressurization, oxygen, wing and engine RDIs. Also hydraulic fluids. The doors are closed. The cabin can be pressurized. The temperature of the brakes and the pressure of the tires. Over here, flight controls, left and right. flight control inputs. You can see the flight controls, the tail, climb and descend, make turns, the rudder. Also FS display over here, maintenance over here, systems menu, circuit breakers over here. So we have also the checklist before going into flight. So we use the checklist like this, normal menu, before start, after takeoff, normal menu, descent, approach, landing. So go back to the navigation display like this. We need to restart the engines over here, so we turn off both engines, so you can see. Fuel control in the off position. You see what it says, both engines are off. You can see the messages are displayed, some warnings over here. So we look outside, we can see we have the engines are going out like this. So we have here, we need to restart the engines from the overhead panel like this, auto start mode. So you see the yellow reconfiguration like this is happening. So you see the engines here. We start the Boeing 787. So we see the views over here. So we need to restart now. We have enough pressurizer, as you can see, from the APU is running into the engines. Above 20% we can start the engines fuel control over here. Move fuel control in the on position like this. So we have the auto start is coming in. We're starting the engines. So we're gonna be having the engines ready in a couple of minutes. You can see auto start. So I'm gonna set the autopilot like this. Auto throttle left and right, on and off, flight director. Over here LNAV and VNAV, the airspeed, guidance. Flight director off. We will disarm the modes. Autopilot disengage the heading and the bang angle. So we set the heading 360 degrees over here. 136, the vertical speed. We can descend, you will see the minus sign, and on climb you see the plus sign. So this is the Boeing calling autopilot, Boeing jet aircraft only. So we have the altitude over here, 35,000 feet, and the thousands, and the hundreds. So we're ready for takeoff. Flaps for takeoff, speed brakes armed. Advance the thrust levers, take the clearance from the air traffic control like this. So we need to taxi into the runway, as you can see. Idle thrust over here. This is also the tiller. The runway is open for us for taxiing to the runway. There's no other traffic. So we align here with the runway center line. So as we can see, so now we're ready for takeoff. I advance. Thank you for watching. I'm Thomas Hatsios, the German American pilot flying the Boeing 787. I just start now the flight of the Boeing 787. Stay with me. So I advance the thrust levers here. Full takeoff. Power. Align with the center line. using the rudder, so advance more thrust, full takeoff power like this. So we pull the side stick down or the yoke until 80 knots or 100, so we get the side stick. So we have V1, we rotate 9 degrees like this and take off very quickly. 9 degrees or less because we're gonna have a tail stripe. Landing gear up. So we have the landing gear up. Like this, we keep climbing as you see. So we have the air data here. As we flying. You see the outside also. We need to descend a little bit the aircraft. So we keep climbing. You can see the data that we have, the terrain. Also, I cannot zoom in for some reason, some kind of problem. So, cockpit, power, outside. So we keep climbing like this. So make the turn now. Full turn. Θεό σου γάμο, το Θεό σου γάμο. Να μην δουλεύει. Τον μπάσταρδο, το Θεό σου γάμο. So we see the outside view, beautiful outside view of the Boeing 787. We make the maneuver here. So it's coming back. As you can see, we can fly either manually or automatically, whatever we like. So keep climbing the aircraft like this. I could not zoom in or zoom out my view before, I don't know why. Now it works. So this is a problem, not be able to zoom in and zoom out to the screens. So you can see the airspeed indicated, the stall speed, the wind direction, the barometric altitude. We are 11,000, the terrain around us, also below. You can see how far below is the terrain. If we look closer or away, some terrain now with green, red, yellow, some airports. So we have also the other side flight plan here also. So we need to level off a little bit here. So you can see the autopilot again, all the views, also the flight management computer here that I have set. So you can see also the airspeeds here, airspeed and altitude here. And also the stall speed, very important, you avoid stalling the aircraft. You can see the stall speed is 120 knots, the wind direction speed, the next waypoint, here's the waypoints in the flight plan. We'll climb with 2,300 feet per minute, you can see the trend line. We'll climb also, we need to make a small turn to the left, and we have a few more minutes for flying the Boeing 787, this beautiful, most beautiful aircraft ever made. So here's a nicer view of the Boeing 787 as we are overflying this area over here. We're very close to France and also Germany, my homeland over here. So we have the lakes here, the Germany, my homeland in front of you, the Switzerland, the France. So we go in here. Again, we cannot. We need to make some turn over here, align with the flight plan, as you can see, as we climb. So we have a few more minutes. We need to come down back to the airport for approach and landing. So you can see again the airspeed, the flight plan we follow over here. So we can override waypoint here from the flight plan, going into the Maldives. Execute actually. So we have some flight management computer problem, a bug actually. So this is how it works. So you see outside over here, we're flying the Switzerland. To come back to the cockpit. So we need to align now with the flight plan like this. So we're leveling off here, as you can see. We have 32,200 feet, flaps up a little bit. You can move flaps up like this. So have to use the controls for the flaps up like this to increase the airspeed. Then we're gonna descend, as you're gonna see. The keyboard is not actually functioning. So we need to make turn here, as you can see. Keep flying. So we have this beautiful view overflying the Switzerland, Germany. Over here, chemtrails. Very beautiful chemtrails. The most beautiful view of the Boeing 787 aircraft, and the star sign, as you can see. So we can flying the aircraft, no problem with that. So we have the Germany, my homeland Germany in the France. So we start the descent now. So we use idle crash over here for descent, and also speed brakes extend to increase the rate of descent. So we're not gonna need any closer views like this right now as we are descending. So we keep descent. Increase the rate of descent over here. Also the view inside the cockpit as we are descending. Full manually, we need to start the turn in 1 minute or so. So we follow the flight plan here. You can see the route we need to follow. So we have some overspeed, no problem for that. We start the turn now, as you can see over here. Oh, we can use some flaps. Extend. So we start the turn and we have a few more minutes left. Keep descending. Increase the rate of descent like this. So we need to align now with the runway, with the flight plan over here as we descend a little bit further, as you can see. So we use left rudder now, aligning with the runway over here, as you can see. We are in alignment. Use also the landing gear, extend in a couple of seconds. So keep slowing down the aircraft. Also align with the flight plan over here. You can see the Lszh localizer. We need to follow over here for approach and landing. We have the information from the Lszh localizer, also the flight plan. So we use landing gear down, flaps also, fully extend. Landing gear down and flaps are fully extend, as you can see. So we use flaps like this, align with the runway for approach and landing, as you can see. So we have 1 minute or less for approach and landing. As you can see, the outside also view over here. So we're going for approach. We're gonna miss one view over here, but it's no problem. We won't have this beautiful view, the outside. So we keep approaching. Very, very beautiful. 2 reds and 2 whites, as you can see. Over here, flare the aircraft, as you can see. As you can see, we have the flare of the aircraft. That's done. So we have idle thrust, parking brakes, and thrust reverser over here. Thrust reverse. Slowing down the aircraft. Align with the center line like this.